Today we will discuss physical tests of meat. A great deal of information can be learned from the basic physical tests of the meat. Meat should have specific odor, color, and textures. Improper processing, contamination, and spoilage each can have significant effect on these characteristics. And those effects can be easily seen, smelled, or felt. Some preliminary tests of meat quality can be done very rapidly with minimum equipment and tools required. First thing is color. Color in meat is probably the characteristic most often used by the consumer when determining the quality of a meat product. Meat color, however, is sometimes misunderstood. The red color in red meat, such as beef and lamb, is not due to blood. It is due to the amount of myoglobin in the muscle. Muscles in animals such as cows contain more myoglobin than muscles from the poultry. Therefore, poultry is generally pale and whitish in color. Myoglobin is basically muscle protein which is used to transport oxygen in muscles, similar to hemoglobin that transport oxygen in blood. When this myoglobin is exposed to UV light, the iron component of the heme fluoresces red. The amount of myoglobin is also affected by how the muscle is used. Heavy use muscles that required more oxygen generally have higher amount of myoglobin. Fresh cuts of heavy use muscles usually appear brighter red on their surface. It is sometimes difficult, however, to judge the quality of a high myoglobin meat based on its color. Just as in live animals, the iron component of myoglobin continuously undergoes oxidation and reduction reactions. Myoglobin in natural meat is usually in one of the three states: myoglobin, oxymyoglobin, and METMYOGLOBIN. Each of these have different state in association with different colors. First is myoglobin. When freshly cut meat has not been exposed to oxygen, the iron is in myoglobin state. The color of the meat is usually purple, red. This color is usually seen in the center of the muscle when the carcass is first cut, before it is exposed to outside oxygen. When it is exposed to outside oxygen, the myoglobin becomes oxygenated and is called oxymyoglobin. The color of this meat is now bright red or pink, which is traditionally called the fresh meat or fresh meat color. Once the fresh meat is exposed to oxygen and becomes red, it can then turn different shades of brown or grey if oxygen level depletes. This is due to the oxymyoglobin undergoes oxidation and lose electrons. This is often seen on the underside sides of the packaged meat, where the top surface of the meat is bright pink due to its exposure to oxygen if the package is oxygen permeable, while the bottom surface, which is exposed to much less oxygen, is usually brown. Once the meat becomes brown due to metmyoglobin, it is very difficult to retain that reddish pink stage again. Incidentally, meat becomes brown during cooking as all forms of myoglobin are broken down. Other forms of myoglobin and impact on color. Myoglobin can bind to other compounds besides oxygen. This can significantly impact the color of the meat. Carbon dioxide binds to myoglobin to form carboxymyoglobin. Such meat can remain pink for extended periods of refrigerated or frozen storage. Nitric oxide also binds with myoglobin to form nitrosomyoglobin, which can also keep the meat pink for very long periods. Both carbon monoxide and nitric oxide are found in smoke. Like in smoked meat, often appears bright red or pink, although they are thoroughly cooked. Nitrites are sometimes added to cure meat, in doing so, creating nitrosomyoglobins. After cooking, those meats will remain pink in color. Here is how the meat pigment changes its color. Okay, the experiment we are going to perform will involve grounded chicken, stomacher bags, oxygen impermeable wraps, refrigerator, and sodium nitrate. In step 1, we will remove the meat from the package, examine the underside to see if the color on the bottom matches the color on the top. Then slice to the meat along its length and examine the color throughout the meat. In stage 2, we will form 2 patties from the same meat package. Wrap one patty in oxygen impermeable wrap and the other in oxygen permeable wrap and place both of them for 1 to 2 hours in refrigerator, and after that we will observe the color changes. Physical signs of spoilage in meat are the clearest indication of spoilage. Among these, smell is the most evident feature that indicates spoilage. Spoilage organisms can change the physical appearance of the meat. Some of the physical signs of spoilage are usually slime formation. Slime often appears on the surface of the meat. If so, they are generally created by anaerobic bacteria. Discoloration of meat, often microbial growth, results in discoloration. This discoloration can appear to be the harmless results of metmyoglobin formation, but discoloration due to microbial growth and spoilage is often accompanied by an off odor. Sticky surface. Molds can produce sticky films on the meat surface. Odor. One of the clearest indication of meat spoilage is its odor. An odorless meat sample is not necessarily safe to eat, but in almost every case the meat has clear off odors when spoiled. Meat should never be considered a sterile product and will always contain bacteria or fungi at different levels. If meat is improperly prepared or stored, these microbes can proliferate. A clear rancid odor is also an indication of putrefaction. In short, this is the breakdown of proteins by different microbes. Often these microbes produce gases. Some of these gases are noxious. Bacteria can also produce other odors during petrification. Thank you so much.